All right, on to part 3 of the exam 3 review video. I pulled up a unit circle to the side here just so we can look at that as we answer some of these questions. So for 25, if cosine of t equals a over b, then what is the exact value of cosine of negative t? So what happens to that value if we negate the input t? So if we think about what that angle is, say that we had positive t was like 30 degrees, right? Well, if we did negative 30 degrees, we'd end up getting 330. And so notice that cosine, which is associated with like our x values, right? Well, we're still on this side of the graph, right? We're still on that positive x side. So actually nothing's going to change. Cosine of negative t will still be equal to a over b. Sine, however, will actually be negative, right? So if we have c over d, and this is positive, if we negate that angle, well, now we're on the lower half of the graph. And so since we're on the lower half and sine is associated with our y values, it's going to be negative c over d. There's our two answers. All right, on to inverse trig. So 26, we want to find the exact value in radians for all of the following questions. So first is arc cosine of 0. So we want to think, well, what angle gives us cosine of that angle to equal 0? Well, we know at 0 it equals 1, and so at pi over 2, this point right here, cosine, or if we think about our x, is 0. And so this angle is going to be pi over 2. All right, now we have arc sine of negative root 3 over 2. So what angle do we get our y to be negative 3 over 2? Well, that's going to be either here or here. And so since they didn't specify an interval of angles to go through, there's actually multiple options here. So we can say 4 pi over 3, or 5 pi over 3, or you can even write that as negative pi over 3. 5 pi over 3 and negative pi over 3 are the same angle. So anything similar to that. All right, on to tangent. Well, arctangent of root 3. So remember, tangent is equal to sine over cosine. And so that means our sine is going to be root 3 over 1. And since all of these have that over 2, we can that cancels out. We can kind of assume that that's what those angles are going to look like. And so when do we have sine and cosine being the same sign, so both positive or both negative, and where our sine has that root 3 over 2 and our cosine is 1/2. And so we can either have it right here, or this is actually another answer we could put, but for simplicity's sake, I'll just say pi over 3 as our answer. And these last three actually play with the idea that the inverse of, so if we have cosine of its inverse, well, those will actually cancel out, and so we'll just be left with the input here. So this should just be negative 1 over root 2. Similarly, arc cosine of sine will cancel out, and we left with 4 pi over 3. And then finally, tan of its inverse, arctan, cancel out, and we'll end up being left with negative 1 there. All right, 27, we have a ski slope, and they want us to find the angle of elevation in degrees. So we have theta here, and we have two side lengths. So if we have two side lengths, then let's use tangent to get our theta. So tangent of theta is equal to opposite over adjacent. And so our answer is going to be arctangent. So theta is equal to arctangent of this value here. And plugging that into your calculator in degrees, remember that your mode needs to be in degrees since we're asking for degrees here. We're going to round the answer to the nearest tenth of a degree, and so that's going to give us about 38.9 degrees is our answer. All right, that's it for inverse trig. On to section 9.1. So we want to find the exact solutions to these values, and we're working in radians now. So here we have an equation with sine of theta on both sides. So I'm going to start by distributing this 5 bring down sine of theta. And so now I'm going to move all of the signs to one side, and then so I'm going to subtract 3 sine from both sides and add 5 to both sides. So we'll be left with 5 sine minus 3 sine is going to leave us with 2 sine. Negative 7 plus 5 will give us negative 2. Dividing both sides by 2, we'll get sine of theta is equal to negative 1. And what angle of theta do we get sine of theta to be negative 1? Well, that's going to be theta equals 3 pi over 2. Now I have a few more finding the exact or approximate solutions. So here we go. 2 cosine of theta plus 1. I'm going to start by subtracting 1. So we're going to get 2 cosine equals negative 1. Cosine of theta is going to now equal 1/2 when we divide by 2. And when does cosine equal negative 1/2? Well, if we think about our unit circle, our angle is going to be 2 pi over 3. And so notice that they want all of the exact solutions. So 2 pi over 3 is that first general angle, that's true, but we also keep in mind we're on the same side of the graph, that left side, so we're also going to get 4 pi over 3 as one of our answers. And so those are the two main ones, and we can keep going around the circle, so by adding 2 pi or subtracting 2 pi to get every solution that would make this equation true. And so to account for all of those other cases, we're going to be adding or subtracting 2 pi, so we'll say plus 2 pi k, where k is an integer. And since integers can be negative, that includes the subtracting 2 pi cases as well. So those will be all of our answers there. All right, next we want to find all of the approximate solutions to cosine of theta equals negative 0.43. So that means we're going to have arc cosine of negative 0.43, and that's going to give us roughly 2.02. And so let's think about the circle again. So our cosine equals negative 0.43 at this angle 2.02 radians. And so pi is about 3.14. So we're actually going to get something around here. And so since we're on that left side, which makes sense, if we have negative 0.43, we'll also have that value in that third quadrant there. So if we have 2.02 radians to get to this point, then to get to this point, it's going to be negative 2.02 radians. But remember, we want to be within this interval, so if we want the negative 2.02 answer, we'll need to add 2 pi to get within that interval. And so that's going to give us about 4.26. So those will be our two answers for this question. All right, next we want to find approximate the solutions for this equation here. So I'm going to start by subtracting 7 from both sides. So we'll get 5 sine of x is equal to 3 minus 7 is negative 4. So sine of x will be negative 4/5. And so our x is going to be equal to arc sine of negative 4/5, which is equal to, so we get negative 0.93, but remember we want to be within this interval, so we're going to add 2 pi to that, and so that's going to give us, let's see, 5.36. All right, so that's going to be one of our answers. Remember, similar to cosine, we want to find the other angle that makes this true. So back to our circle. Remember, this is like 3.14, so we're at about 3 pi over 2 is about 4.7. So we're going to be in this quadrant here. And so that means that we're going to have something over here. So if this difference here is negative 0.93, then this distance here should be 0.93. And so we should just get our other angle to be pi plus 0.93, which gives us 4.07 as our other answer. All right, and the final question for this section, find all approximate solutions to tangent of theta equals negative 4.5 on this interval. So arctangent of theta is equal, arctangent of negative 4.5 is equal to our theta. And so plugging that into our calculator, we get negative 1.35. To get that within our interval, we're going to add 2 pi. And so we're going to get 4.93. And so since our tangent is negative, that means that the two quadrants, so since it's sine over cosine, that means we need to be in the quadrants where sine and cosine have opposite signs. So if we have something up here, we're going to have something down here. 4.93 is going to be this angle here. And so if we subtract pi, since we're all the way on the other side, we should get our last angle to be about 1.79. And those are our two answers there. All right, on to compositions. So a rock is tossed into a pond that creates a circular ripple with area measured in square meters when it has radius r meters. And the radius r is also a function, h of t, where h of t meters at time t seconds after the rock hits the water. And so what is the meaning of f of h of t? So f of h of t is the area of the circular ripple measured in square meters as a function of our input. Our inner input there is t. So on the outside we have f, on the very inside we have t, so it's a function of time, t seconds. On to the last page of this part. So we're going to find two different possible formulas for g and h, given that the composition is equal to this fraction here. So the first thing I want to notice here is we can actually factor this to be x plus 6 squared. And so that opens up a couple opportunities for g and h here. So notice we have this rational, this 1 over some function. So if we let our outer function g of x be 1 over x, then we can have our h of x to be this x plus 6 squared. And so we would end up getting that composition, so that's going to be one of our solutions. But because it's squared down here, we can also let our g of x not just be 1 over x, but be 1 over x squared. And then we'll let h of x just be x plus 6. So there's two possibilities. All right, 35. We want to let p of x equal 2x minus 3 and q of x equal root x minus 3. And we want to find u so that q of x equals p of u. So p of u, well, I'm going to plug in u for all of our x's, so it'll be 2u minus 3. And so we want p of u to be equal to q of x. So q of x is square root of x minus 3. Adding 3 to both sides gets rid of this. So we end up getting 2u of x is equal to the square root of x. So finally, our u of x is going to be 1/2 times our square root of x. All right, 36, let f of g of x equal 3 natural log of 2x minus 1, and g of f of x be the natural log of 6x minus 2. So notice we have a natural log in both of these. Here, natural log is the outer one, and here kind of looks like natural log's on the inside. So since g of x is in the inside here, outside here, I'm going to let g of x equal natural log of 2x. And now knowing that, well, 6x minus 2 is the same as 2 times 3x minus 1. And notice here, if we let this be x, we get 3x minus 1 in there as well. So f of x will be 3x minus 1. All right, now using this graph of f and g, we want to solve each of these equations. So first we want to solve for x when knowing that f of g of x equals 1. So on these problems we want to solve for x, so we need to start on the outside and make our way to the inside. So when does f equal 1? F equals 1 at this point here. So f of g of x equals 1 whenever g of x, so our input here, is equal to 3. And so now we want to find, well, what value of x do we get when g equals 3? G equals 3 right here, so our x is going to be equal to 2. Similarly, we want to solve for g of f of x when, x when g of f of x equals 5. So, let me erase this a little bit. So, when does g equal 5? G equals 5 here, so that's when f of x, our input, is 4. When does f equal 4? Right here. So our x in this case is going to be equal to 0. All right, f inverse of 3. So we want to find, because we're dealing with inverses, these inside parts are going to be our y. So we want to find the x where f of x equals 3. So when does f of x equal 3? That's going to be right here. And so our answer for this one's going to be 1. Similarly, what value of x does g of x equal 4? Well, g equals 4 right about here. So our answer for that one's going to be 3. And now finally, so we want to, instead of working our way backwards, we're going to start on the inside and work all the way out. So we want to find f inverse of 1. So what value of x does f of x equal 1? F of x equals 1 about right here. So we end up getting g of 3. And g of 3 equals 4. So that'll be our answer there. All right, last question for the part. We want to let r of x equal 3x minus 4 over 2x plus 5, and we want to find the inverse. So what I'll do here is I'll set r of x equal to y. And now we want to manipulate this a little bit and get all the y's together and solve for x. So I'm going to start by multiplying 2x plus 5 to both sides. And the goal here is to try and get all the x's together. So now I'm going to distribute that y. So we'll get 2xy plus 5y. And then now I'm going to subtract the 3x and the 5y so that we get all the x's on one side together. And now I'm going to distribute out the x. So we're left with 2y there, negative 3 here. And so dividing by 2y minus 3, we end up getting x is equal to negative 5y minus 4 over 2y minus 3. And this is going to be equal, dealing with r inverse, which is a function of y.